All right, welcome back to the deep dive. Today we are strapping in for a uh, really high velocity look at global trade.
And we're going right to the heart of it.
We are. We're focusing on what is probably the most complex, most critical node in the entire supply chain, the
Ah.
smart port.
Mm-hmm.
And we're here because we are seeing something that a lot of people in the industry are calling, well, a quantum leap.
It really is. It's this moment where automation software shifts from being just predictive to being genuinely agentic.
And that's a huge distinction.
It's a critical one.
Yeah.
And for you listening, the setting here is so important. I mean, modern ports are just getting slammed by challenges that were, almost unimaginable a decade ago.
We're talking about massive growing cargo volumes hitting these choke points.
Exactly. And they're caused by things you can't really plan for. Geopolitical shocks, sudden trade route shifts, extreme weather, and these delivery windows that are just getting tighter and tighter.
And traditionally, the way ports handled this was, well, it was kind of rigid, right? They relied on systems built on old data.
Old data and fixed schedules. They could forecast, but they couldn't adapt.
So it was always looking in the rearview mirror.
Precisely. That traditional approach, using these fixed algorithms based on last quarter's numbers, it just led to huge inefficiencies. You end up with, constant congestion, really costly delays because the system just can't reallocate resources fast enough.
The system just plateaus.
It plateaus because it's rigid. It can't sort of negotiate its own recovery when things go wrong.
So that's our mission in this deep dive. We're going to explore this massive shift happening right around 2025 from that rigid, rule-based automation to this dynamic, goal-oriented world of agentic AI.
We're moving from fixed scripts to what is basically continuous multi-party negotiation.
All orchestrated by software.
Yeah. And it's important to define that generational shift really clearly. Traditional automation is, for lack of a better word, passive. It follows a script. It does scheduled tasks.
And it needs a human to step in the second something unexpected happens.
Right. If the schedule says a ship arrives at 8 a.m. and it shows up at 9, the whole system either breaks or just stalls until someone fixes it.
So, agentic AI, how is it fundamentally different?
Well, instead of one central brain telling everything what to do, you have to imagine it as multiple interacting decision makers.
Like a team.
Like a team of agents, and they're all goal-oriented. They're processing these colossal real-time streams of input, everything from AI feeds, the automatic identification system,
Right, every ship's location.
to IoT sensor data from the cranes, to the logs from trucks checking into the gate.
And they don't just report that data.
No, that's the key. They fuse it all together into one complete operational picture, and this is the crucial part, they autonomously negotiate decisions. They're constantly trying to achieve a goal, like maximizing throughput by juggling all these variables.
So if the old system said, Crane A must service ship 1 at berth 3, what does the new system do?
Well, the new system has a crane agent, a berth agent, and a vessel agent. And they're all talking to each other, negotiating the most efficient use of those resources in that exact moment.
So they might ship 1 to berth 5 just because the agent saw that the truck queue at berth 3 was getting too long.
That's the orchestration value right there. This approach is just uniquely suited for the chaos of port operations. If a vessel schedule changes, classic engine trouble, a weather reroute, the old system waits.
Waits for a person to fix it.
Right. An agentic AI, on the other hand, is designed to instantly trigger this system-wide negotiation to adapt on its own, minimizing that ripple effect from the delay.
That really is the quantum leap. The software isn't just following rules anymore, it's actively solving bottlenecks as they happen.
Let's really dig into what that looks like on the ground, that dynamic bottleneck resolution. When a vessel reroutes or, has a sudden delay, the agents don't just send an alert.
They do something about it.
They immediately kick off corrective actions across the entire terminal operating system.
Okay, so walk us through a scenario. You have a huge container ship. It's scheduled for 2 p.m., but it reports a 4-hour delay because of, say, heavy seas.
Okay, in the old system, that 2 p.m. slot just sits there, empty, cranes are idle, the truck appointments are now useless, and you get hours of trucks waiting on the road.
Creating a huge traffic jam.
Exactly. With agentic AI, the vessel agent tells the TOS about the delay. Immediately, the berth allocation agent sees that newly freed up 2 p.m. slot, and it also sees a smaller feeder vessel that's already waiting at anchor for a 6 p.m. slot.
So the agents negotiate a swap?
A dynamic berth swap, yeah. The feeder vessel gets moved up 4 hours.
Okay, that's a big efficiency gain right there.
But it doesn't stop. Simultaneously, the crane tasking agent sees the equipment that was scheduled for that delayed megaship is now free. So it rapidly resequences its tasks to unload the feeder vessel that just got moved up.
And what about the trucks, the ones that were supposed to pick up cargo from the big ship?
Right. The trucking agent immediately integrates with the vehicle booking system, the IVBS, and autonomously reschedules hundreds of appointments for those trucking firms. It sends out the new windows
And all of this happens. How quickly?
in seconds, or maybe a few minutes. This negotiation, which involves an AI agent talking to the ship, the TOS, and all these external trucking firms at the same time, it just cuts out all the friction.
The friction that costs ports millions.
Millions.
Yeah.
It slashes operational costs by getting rid of that expensive idle time.
So the whole automated workflow just becomes incredibly smooth. A shipper sends an updated ETA.
The TOS gets it, notifies the AI agent, and the agent just resequences everything, cranes, trucks, and sends out automated, verified status updates to everyone down the line.
So what's the big benefit for the human teams here? I mean, this has to shift the entire focus of their labor, doesn't it?
Completely.
Yep.
It pulls the human team out of the tedious, time-sucking routine. No more constant phone calls, no more endless email chains, just to resolve a simple conflict.
So they become managers of exceptions.
That's the perfect way to put it. If a real anomaly happens, say a crane needs an emergency shutdown, the agent flags it, suggests a plan, and the human supervisor steps in to make the final strategic call.
This shift in labor really brings us to a crucial point. Where exactly do humans fit into these new autonomous workflows?
Right.
Our sources lay out two main philosophies here. Human in the loop, or HITL, and human on the loop, or HOTL. They sound similar, but in a high-stakes place like a port, they're worlds apart.
They really are. They represent the whole spectrum of human oversight.
Mm.
Let's start with human in the loop, HITL. This is
Right.
where you have active, hands-on involvement in developing and training the AI model itself.
So the human is basically the teacher, actively correcting the system's homework.
Precisely. HITL roles are things like data annotators, domain experts. They're validating the training data, tweaking the algorithms, providing constant feedback. A port analyst might, for instance, spend time labeling thousands of old delay reports to teach the AI the nuances of why a delay happened.
Was it customs? Was it weather? Was it a mechanical failure?
Exactly. That kind of hands-on work is critical to make the models accurate enough to handle the complexity before you let them run loose.
Okay, so HITL is all about quality control and education during the AI's development. What about human on the loop, HOTL?
HEL is a supervisory role. This is during live operation. The key difference is the AI system is running autonomously. It's making decisions, executing commands, coordinating moves on its own.
And the human is just watching.
Monitoring a dashboard, yeah.
Yeah.
Watching for alerts. They only step in when the AI runs into a predefined anomaly, an edge case, or a critical decision that crosses some kind of safety or risk threshold.
Can you give us a concrete example of that HOTL role in a port?
Sure. Think about that berth allocation agent. It's autonomously assigning berths based on maybe 20 different factors. But let's say sudden, dense fog bank rolls in that wasn't predicted. The system might calculate that visibility just dropped below a safety threshold set by the IMO. The Agentic AI would immediately suggest grounding all pilots and stopping crane movements. That's a huge critical decision. A human supervisor in an HOTL role, sitting in the control tower, gets that high priority alert and is the one to confirm the override.
So you get the speed and efficiency of the AI for 99% of the routine tasks.
Right.
But you still rely on human judgment for that 1% of high-risk situations where safety is everything.
That's the balance. For these high-stakes, time-sensitive port operations, the design has to move toward HOTL. Can't sacrifice the machine speed on routine stuff, but you absolutely have to keep a human's ability to override critical decisions. The human becomes the strategic safety net.
I have to jump in with a point of skepticism here, though, that's rooted in the politics of logistics.
Go for it.
You mentioned the agent negotiates with the TOS and external partners like trucking firms, but data sharing has always been the biggest political bottleneck. Companies live in silos. They don't want to share proprietary data. How does this even work if the data pipeline is blocked by corporate reluctance?
That's an excellent challenge. It's a real one. The success of this whole thing absolutely depends on breaking down those silos. The sources point to two main strategies. First, what you could call standardization through necessity.
Meaning,
when a major port adopts a system that requires a standard API for, say, ETA updates, all the external players are basically forced to comply if they want to keep doing business there.
and the second strategy,
The other big piece is the rise of secure distributed ledger tech, like blockchain. This gives you a way to share verified operational data, like a container status, without revealing your company's secret sauce, like pricing data.
So the agents are negotiating based on facts that everyone agrees are true because they're on a trusted ledger.
Exactly. The trust is baked into the technology itself.
Okay, let's get into the engine room then, the data science.
Hmm.
You can't just deploy an AI agent in a physical port without building the right tech ecosystem first.
No, you can't.
The sources are clear on this. You need three foundational pillars: robust data governance, digital twins, and simulation capabilities.
And these are all about safety and certainty. Data governance is the absolute foundation.
Yeah.
It's not just security, it's about quality. These agents are data hungry. If the data is garbage, their decisions will be garbage.
Garbage in, garbage out.
Always. Governance ensures the data is clean, accurate, and traceable.
Then you have the digital twin, which is basically the AI's real-time playground.
Correct. It's a virtual, live replica of the physical port, the exact location of every crane, every truck, every container. This is where the agents can run tests and predict outcomes before they actually commit to moving a real-world multi-ton piece of steel.
And the third pillar, simulation, that's where you get the proof that this will actually work. We saw a really compelling case study on this from a Panamanian container terminal, the Port of Balboa. They used something called discrete event simulation.
Right. And they use business process modeling notation, or BPMN, which is just a standard way to map out complex processes.
Right.
In this case, the whole berthing process. Arrival, pilots, customs, loading, unloading, everything.
So it's like a digital stress test for the port's procedures.
And the results were so revealing because they finally quantified the hidden costs of all this waiting. They found this huge disparity based on how big the vessel was.
Tell us about that. What was the quantifiable inefficiency?
Well, the big post-Panamax vessels, the ones on the main global routes, they had manageable wait times, around 10% of their total time in port. They have leverage,
Yeah.
But the smaller feeder vessels,
The ones doing the regional distribution?
yes, they were seeing devastating waiting times.
Yeah, how devastating.
Up to 40% of their total time in port was spent just waiting, in 75% of cases.
40%. What does that translate to in real hours?
It's anywhere from 4 to 15 hours, just sitting there, burning fuel, waiting for a berth, or waiting for customs because the schedule is too rigid to accommodate them. And that's not just wasted time, it's hundreds of thousands of dollars in fees and disruptions down the line.
That kind of data makes the case for autonomous agents pretty undeniable. But, okay, before an agent can even schedule a vessel, it has to know exactly where the berths are. And that's surprisingly hard because port documents are a mess.
It is. And this brings us to the really clever part, the autonomous berth localization method. This is a deep dive into unsupervised machine learning, solving what's called the data gap problem.
Because you can't trust the human-labeled maps.
You can't. They're often wrong or incomplete, so you have to rely on real-time data streams, specifically AIS data.
And we're talking about 310 billion AIS messages a year, every ship broadcasting its location. How on earth do you turn that noisy river of data into a precise static map of a port berth?
You have to use this really ingenious two-stage design to find the signal in all that noise. You have to figure out if a ship is just passing by or if it's actually moored.
Okay, break down stage one for us.
Stage one uses a ship-level clustering algorithm called DBS scan. The easiest way to think about DBS scan is it's a way of finding dense neighborhoods in a sea of data points. When a ship is just moving, its AIS points are scattered. When it moors, its points pile up in one tiny area for a long time. DBS scan is programmed to ignore all the scattered points, the noise, and only keep the dense clusters where a vessel stayed put.
So if a ship stops for 2 minutes, DBS scan ignores it, but if it's there for 4 hours, that becomes a valid cluster.
Exactly. It filters out all the passing traffic, so you know you're only looking at points that represent an actual berthing event.
Okay, so now you have these clusters of stopovers. Stage 2 uses something called Gaussian mixture models, or GMMs. What are they doing?
GMMs take those individual stopover points and draw a precise, continuous boundary around them. You can think of it like a sophisticated digital rubber band. It analyzes the spatial pattern of all those points and figures out the most statistically likely shape of the actual berth area.
So it gives you a clean polygon, an exact digital outline of the operational space.
That's it?
I can see how that's powerful. But let me play the skeptic again. This whole process is based on GPS points. What if you have a massive 400-meter-long ship and the AIS is only reporting the location of the bridge at the center? You could end up with a map that doesn't account for the ship's actual footprint.
That is the exact weakness of raw AI data, and it's where the researchers introduce their most critical innovation: spatial data augmentation.
Okay, what is that?
They realized a vessel isn't just a dot, it's an area. So they used the vessel's dimension and heading data, which is also in the AIS stream. For every single real AIS point, the system calculates the physical area the ship's hull is occupying and then generates synthetic data points inside that footprint.
Ah, so it's filling in the blanks. It's giving the algorithm a much more realistic picture of the physical space being used.
It's a game changer. It moves the system from seeing a single dot to seeing a whole coherent shape. And that leads to vastly more accurate berth outlines. This is what turns the GMM polygons into maps you can actually rely on.
Speaking of efficiency, you're dealing with so much data. The researchers also used something called geohash encoding, and I remember the results on speed were pretty staggering.
Geohash is simple, but so effective. It's basically a way of binning the entire planet into a grid. They bin the data into these small squares, about 4.8 meters by 4.8 meters. This declutters the dataset without losing the detail you need.
So instead of comparing billions of individual points, you're comparing millions of small indexed squares.
And the computational result was this massive speedup. Across 11 different ports, the average runtime for the whole process dropped from almost 5 minutes down to about 2 minutes.
Wow, more than twice as fast.
Almost a 60% reduction.
Yeah.
It's what makes the system fast enough for real-time use.
But speed is one thing, accuracy is another. How did this method stack up?
They used a metric called the mean Poitrage distance, or BD, which basically measures how similar the generated cluster is to the ground truth.
Lower is better, I assume.
Much better. Their proposed method, with geohash, got a BD score of 0.836, which is incredibly consistent. For comparison, a competing benchmark method scored 13.780.
That's not even close.
It's not an incremental improvement. It's proof that this system works on a whole other level.
So why should a port manager care about that number?
Because that level of accuracy means the agentic AI knows the precise, reliable dimensions of every single berth. That prevents very costly mistakes, like trying to schedule a huge vessel into a small space. It means the agent's decisions are grounded in a reliable digital map of the real world.
It's fascinating. The sources said this system actually identified working berths in places like Cape Town that weren't on any of the official third-party maps.
Right. The AI found the operational reality that the official documents had completely missed. It's just validating and correcting human data based on where ships actually go.
So we've built the foundation, we have autonomous agents that can negotiate, and systems that can map the world they operate in. Let's talk about the tangible gains. Where are the highest value use cases right now?
They really cluster around 3 big areas: port call orchestration, optimized berth allocation, and proactive anomaly handling. Berth allocation is a huge one because the agent is juggling vessel size, cargo type, crane availability, even tides all at once.
And these are the things that directly cut down on how long ships are sitting around.
Exactly. They lead to higher throughput and radically reduced dwell time.
Okay, let's quantify that. What are the metrics we're seeing in the real world?
The trials are showing that this kind of automation can reduce a vessel's total port stay by up to 30%.
30%, that's huge.
It's a massive number. And it's achieved mainly by cutting down the time ships spend waiting at anchorage outside the port, which is a major hidden cost. For a big ship, every hour spent waiting is tens of thousands of dollars down the drain.
How is that 30% actually realized, though? Walk me through it.
It's a cascade effect.
Yeah.
It starts with an accurate ETA, which lets the agent negotiate a slot immediately. The agent knows the crane availability, so it can pre-stage the equipment and labor. When the ship arrives, unloading starts instantly.
So you're just systematically eliminating all the non-value-added waiting time.
That's it. Reduced idle time, lower dwell, faster turnaround.
And the port isn't an island, it's the link between sea and land. This is where multimodal synchronization becomes so important.
Absolutely. The agent's highest value might be in coordinating across sea, road, and rail. Imagine containers coming off a ship that are headed straight for an inland rail hub.
In the old system, they'd get unloaded, put in a stack, and then someone from the rail company would call to arrange a pickup. Lots of shuffling, lots of delays.
Right. With an agentic AI, the system knows the exact moment that container will be available. The rail agent tells the rail yard management system, and the trucking agent, through the IVBS, make sure the truck arrives at the precise moment it needs to.
A seamless handoff.
A seamless handoff that ripples through the entire supply chain.
The efficiency gains are clear, but I also want to touch on sustainability, because that's being driven by dedicated agents too. Let's look at the voyage optimization agent.
This is a powerful one for both the planet and the wallet. This agent doesn't just find the shortest route, it finds the most eco-efficient one. It analyzes real-time data on currents and weather and the schedule at the destination port.
And it adjusts the ship's speed.
Right, a practice called slow steaming. It makes sure the ship arrives just in time, so it doesn't have to speed up and burn extra fuel or wait for hours at anchor, burning fuel.
And what are the savings?
They're substantial. Some trials are reporting up to a 20% reduction in fuel costs. That directly cuts carbon and sulfur emissions. A schedule delay goes from being a problem to being an opportunity to save energy.
And while the ships are running cleaner, you still have to maintain the port's physical assets. That's where the predictive maintenance agent comes in.
This agent uses IoT sensors to monitor the health of everything, cranes, tugs, tractors. Instead of fixed maintenance schedules, it uses machine learning to spot tiny signs of trouble before they become a failure.
So instead of a crane breaking down in the middle of a shift and causing hours of chaos,
The agent flags a potential issue, and the maintenance team schedules a repair during a planned downtime. It reduces unplanned downtime and just makes the whole operation more resilient.
this all paints a picture of a totally collaborative environment, the smart port ecosystem. And it sounds like this relies on more than just AI.
It does. IoT is the input, that's non-negotiable. But the real collaboration glue is blockchain. Smart ports need a single source of truth that every single party, shipping lines, terminals, customs, can trust without question.
Because if these agents are making instantaneous decisions for competing companies, those decisions have to be based on facts that everyone agrees are real.
And that's the blockchain synergy. When an agent updates a record, say confirming a container has cleared customs, that update is instant, verifiable, and permanent on the ledger. Everyone is working from the same playbook.
Of course, all this power comes with huge responsibility. We're talking about autonomous systems controlling billions in assets and very dangerous machinery. The biggest challenge has to be trust and safety.
It's foundational, and it requires really strict governance from port authorities. The core idea is that the human must always have control and understanding.
What are the key safety requirements?
First is explainability. The human operator has to be able to see how the AI reached its conclusion, not just what it decided. If an agent recommends a risky move, the operator needs to be able to quickly see the why.
Right, so it's not a black box. That's critical for accountability.
Absolutely. Second, audit logs. Every single action, every negotiation, every data point has to be logged immutably. And third, a clear path for safe fallbacks. There has to be a big red button, so to speak, an immediate way for a human to take over.
I appreciate that emphasis on human judgment. Even the best AI can't be trained on every possible black swan event.
And that's where the human supervisor is the critical safety valve.
For a port authority looking at this, they can't just flip a switch overnight. What's the recommended way to pilot this and de-risk it?
It has to be phased. Phase 1 is just data readiness. Map and clean all your data sources. Phase 2, pick one small, manageable use case. Don't try to boil the ocean. Start with just berth planning for one key.
And then comes the testing.
Yes, the crucial shadow mode deployment. You run the AI in parallel with your human operators. The agent makes its decisions, but they aren't executed. They're just logged and compared against what the humans are doing.
So it's like a simulator running in the background proving its worth before you hand over the keys.
Exactly. Only when it consistently hits its KPIs, like reducing wait times, do you move it into live operation, and even then it's under strict human-on-the-loop supervision.
The sheer volume of valuable data here, trade secrets, cargo manifests, must make cybersecurity a massive risk.
It's the silent threat. As these systems connect everything, the digital attack surface just expands exponentially. Protecting that data from being stolen or manipulated is absolutely critical.
We also have to address the elephant in the room, the workforce. Is this going to lead to mass job elimination?
The evidence all points to a job shift, not elimination. This tech is designed to automate the repetitive, low-value cognitive stuff.
The endless emails, the copy-pasting of schedule.
All that operational busy work, so the labor gets repurposed for higher-value work.
So skills shift towards what?
Towards critical thinking, exception handling, long-term strategic planning, managing the AI systems themselves. Port workers go from being data entry clerks to being control room supervisors and logistics strategists.
And for the port as a whole, that resilience factor is huge.
It is the ultimate competitive advantage. An agentic system lets a port adjust on the fly to a major storm, a customs change, a supply chain shock. That agility is what protects it from global volatility.
So looking ahead, what's the research roadmap from here?
The main focus is on enhancing reliability. A big part of that is extending the observation period we talked about earlier, from just 1 month to multi-month or even seasonal windows.
And why is that seasonal data so important?
Because some berths are only used intermittently. You might have a berth that's only busy during the mining season, for example. If your observation window is too short, the AI never sees it. You need a full year of data for a complete picture.
And the goal is still a universal model.
Absolutely. The focus is on developing robust, fully unsupervised models that you can deploy at any port in the world, as long as it has enough AI's data. The ultimate goal is a universal, reliable, smart port brain.
This has been an incredibly intensive look at a huge transformation. To just synthesize the key takeaways, we've moved beyond static scheduling to dynamic, multi-agent systems that are constantly negotiating and adapting.
And we've learned that this is all underpinned by some serious data science. The ability to autonomously map a port's physical footprint using unsupervised methods like DBSCAN and GMM, supercharged by spatial augmentation.
And the results are concrete: up to a 30% reduction in port stay time, up to 20% savings in fuel costs. This technology is actively building the efficient, coordinated, and resilient smart ports we've been promised for years.
But this whole system of autonomous negotiation, it raises a really critical final thought for you, our listener. We've established that these systems can optimize a single port in minutes. But if the next wave is fully autonomous, end-to-end supply chain negotiation.
You mean where an AI from one shipping company is autonomously negotiating prices and slots with an AI from a competing terminal?
Exactly. With no human input at all. What new legal, commercial, and frankly, ethical frameworks do we need to put in place today to govern the interactions between these fully autonomous, economically competing agents?
That is the core challenge of the next 5 years, isn't it? Defining the rules for machine-to-machine commerce on a global scale. This deep dive has really underscored how knowledge and logistics, digital supply chain automation, and blockchain is all converging to create the competitive advantage of tomorrow. Thank you for joining us on the deep dive.